In this video, we're going to calculate the time of flight of a ball that is released from rest from an altitude of 100 meters. So if we go ahead and draw a simple picture of the situation. So we have a person at the top of a 100 meter tall building, say, and this is the ground here. We want to know how long it takes a ball that is released from rest, so the initial velocity is 0 meters per second. How long is it going to take that ball to hit the ground if it travels along this straight line path? The first thing we should realize is that the displacement in the y direction is given. Since displacement is y final minus y initial, it's very important that we define an origin. So we could actually set our origin to be the ground. So that's y equals 0 meters. So that's actually y final because that's where the ball ends up. So therefore our y initial is 100 meters above the origin, which means the y initial is positive 100 meters. So if we go ahead and calculate our y final minus y initial, we'll have 0 meters minus 100 meters. So our displacement is negative 100 meters. Now keep in mind, displacement is a vector. So the negative sign makes sense because it would indicate the direction, which is down. So we can go ahead and write our kinematics equation. Delta y equals 1/2 acceleration in the y times time squared plus the initial velocity in the y times time. Now the reason I'm writing a subscript for the acceleration and the initial velocity is to emphasize that we are dealing with y motion. So we're dealing with vertical motion, so y direction. Now we know that the initial velocity is 0, so this term vanishes. Delta y is negative 100 meters, and that's equal to 1/2 the acceleration in the y direction. Since the only force acting on the ball is gravity, the acceleration in the y direction would just be the acceleration due to gravity on Earth, which is negative 9.8 meters per second squared, and then multiplied by time squared. So we have an equation with one variable, and we can go ahead and solve for that one variable, which is time. So the negative signs actually you can cancel from both sides. That's just multiplying both sides by -1. And just omitting the units for a minute, we have 100 is equal to 4.9 times t squared. We can divide both sides by 4.9. And that leaves us with t squared is equal to 20.41. And we actually have two solutions to this equation because remember from math that when you take the square root, you should really take plus or minus the square root. But we know that time can't be negative because that would mean that the ball hit the ground in the past. So we're only going to take physical solutions, which means that time should be positive. So the ball should hit the ground in the future. So if we take the square root, we end up with 4.52 seconds. So it takes 4.52 seconds for this ball to hit the ground if it's released from rest 100 meters above the ground.